I'm Petar Tsankov. I'm a co-founder and chief scientist at ChainSecurity. We're a blockchain security startup based in Switzerland. And I'm also a senior researcher at the I Center of ETH Zurich. And I'm going to talk to you a little bit about security of blockchains, because blockchains, as we all know, they provide a nice, secure infrastructure, but we really have to use it correctly in order not to lose funds. So a little bit of to introduce the teams working behind all this work. So on the left, this is the research team. We're based at the I Center at ETH Zurich. We are the we have the top computer science department in Europe. We work on different topics. Blockchain security is one of those. And then ChainSecurity on the right. So this picture was shot when we were in Prague with the team a couple of weeks ago. So we are a spin-off from the I Center, where we commercialize all the research security product that we're building over there. So security is really one of the fundamental issues that we have to solve if we're going to make this technology to work in the future. So this year, there's about $1 billion worth of USD that have been lost due to various number of hacks. And most of these hacks actually appear due to people not using, incorrectly implementing the smart contracts which they deploy on the blockchain. So we want to solve this problem, and to address this problem, we need to understand where security issues appear in these smart contracts. Why do we have this problem? And then think about what we can do in order to solve that problem. And if we look at the life of a smart contract, you would see something like this. So first, you would have developers that would start implementing the smart contracts. And the main challenge here is that typically these smart contracts are written in new languages. They are executed in new environments. And developers are not yet super familiar how to use it correctly. And they just often introduce silly mistakes that end up in really bad consequences, people losing literally millions worth of USD. Once the contracts are developed, then they're deployed on the blockchain. But before we do deploy on the blockchain, always the smart contracts go through an independent third-party audit. And the point of this part is basically to certify to the users of the smart contract that whatever is implemented in the code actually corresponds to some high-level description of what the contract is supposed to implement. The challenge here is that, well, these audits are done completely manually today, which means people manually look line by line and trying to understand what these contracts actually do. And this is a really hard problem that doesn't scale, and you cannot do it manually in the future. Once the audit is done, these contracts are deployed on the blockchain, and then the challenge is that there's no really easy way to track what is happening to the smart contracts and if there are any kind of anomalies or hacks that are being done to the contracts. So to solve these problems, we're working on all these dimensions. So to help developers, we're building advanced automated tools that would help them eliminate security issues while they're building the smart contracts. We're also using this technology to provide machine-checked audits for crypto projects. So the idea here is that we do, instead of only relying on people to understand if the contract is correct, we also have technology and products to automatically check that this is actually provably correct. And then we also have monitoring solutions that would help all these blockchain projects to track exactly what's happening to their smart contracts and to quickly react if there are any kind of security issues happening while the contract is on the blockchain. So I'll give you a very short introduction to what is happening in this space. As Emma mentioned at the beginning, all these things are actually working. And if you just come to the booth, I'll be very happy to demo how this actually works in practice. All right. So in the space of the automated tools, the first most major issue that's happened last year, there were several significant bugs. Like there was the DAO bug, there were several bugs in the parity wallets. And if you really look at these security issues, they were really embarrassingly simple. So to address this problem, we built a very easy to use scalable security scanner for smart contracts to help developers not do these mistakes anymore. So literally, to use this kind of system, developers could simply paste the source code of their smart contracts, and then they can click on one button to check if there are any kind of generic security vulnerabilities in the code, and then the system would highlight all the issues that could appear in the contract and provide additional information to tell the developers how to fix these issues from the contract. This system, by the way, is publicly available on this website because we want to make sure nobody makes these mistakes in the future. So this system, yes, available publicly on this website. Also, we have open source system. A few months ago, it was officially funded by the Ethereum Foundation, so we're working directly with them to bring this closer to the developers. And we have also channels where we can engage with the community to get feedback and further improve this kind of products. Okay, so this first system, it is really good at detecting these generic vulnerabilities that no smart contract should ever have. However, this is not enough to secure a smart contract because when you write a contract, you typically have some very specific functionality in mind that this contract is supposed to implement. So it's not a generic vulnerability, but these are specific things you want the contract to do. In order to make sure that these are correctly implemented in the contract, we have built a symbolic verification system that can automatically certify the correctness of the contract. So just to give you an example of what are the capabilities of such a system, well, typically, in a smart contract project, you would have the smart contracts, like let's say you have a crowd sale or escrow smart contracts to make a crowd sale of your project. And then there will be a bunch of methods and functionality that you developers would write in order to make this project operational. Then typically you would have some very specific requirements that you would want to make sure is correctly implemented in these smart contracts. For example, if you have an escrow contract that is supposed to hold all the funds invested during the crowd sale, you would want to make sure that the sum of all the deposits in this escrow contract would be always equal to the balance of the escrow. So this actually means that if this doesn't hold, the escrow contract doesn't actually hold the funds. So that's important to ensure. Other common things you want to ensure is that, well, investors should not be able to claim any refunds unless if the crowd sale is successful, so if enough funds have been raised during this crowd sale. So there are typically many such requirements that you would have to make sure are correctly implemented in all these functions of these smart contracts. So to check that these requirements correctly hold is actually very, very challenging. And let me give you a very high-level intuition of why this is hard. Well, once you deploy the smart contract, the smart contracts are some initial state that defines that's the initial state of the contracts once you put them on the blockchain, and then users can start making transactions. So each of these arrows here, they indicate you make a transaction and then the contract transitions to a new state. And the problem here is that users can send many, many transactions, and then this keeps going on for literally forever. And the breadth of this tree that you would want to verify is really impossible because there's just such a vast number of transactions users can send that you cannot enumerate all these transactions and run them on the contract. The other challenge is that there's unbounded depth, meaning that users keep sending more and more transactions, so it's a very hard problem to brute force this state space here. So to solve this problem at a very high level, what we have developed in the lab a technology where instead of enumerating individual transactions, we could actually only enumerate them in a more symbolic way, where we can essentially make this width of this tree feasible to inspect. And also we have come up with different levels of abstractions to bound the size of the depth of this tree, so we could actually explore all the possible states that your contracts can get into, and then we can verify the requirements you have in mind hold or not. So these systems are fairly low level to use because they're used by security experts, but essentially what this technology allows is that developers can precisely formulate what the requirements are. So there's a specific language in which they would use to define those requirements, and then the system would automatically run and check them if the implementation of the contract is correct or not. And the main guarantee here is that if the system certifies the behavior, then it certifies correctness for any sequence of transactions of any length, which is the highest level of guarantee you would want to have for the smart contract. So again, the system is also working, so if you come by the booth to me, I will be also happy to demo it to you. So the final level of technology that we have built, also we have looked at using machine learning to do better testing of smart contracts. And so what is testing? Testing simply means that you essentially generate random transactions and you run them on your contracts, and then you see if the contract works correctly or not. And one of the interesting insights is that, well, the main challenge is understand what transactions actually make sense to be executed on the contract. And we essentially try to leverage machine learning to learn which transactions are interesting. And in the case of blockchain, that's the opportunity here is that you actually have all the transactions that have ever been created by users stored on the blockchain. So you could take these huge amounts of data and learn from it, and then use this to ensure the correctness of the smart contract by testing it using this knowledge. I can, again, I will not go in detail, but if you come by me, I can give you more detail on how this is actually done. All right, so this is the core technology that we have built in the lab and in the company. And we have bundled this technology to provide security machine-checked audits for crypto projects. The way this works is that we have built an audit platform that integrates these different pieces of technologies. This platform takes as input the smart contracts that you want to certify, together with the specification of these contracts that defines the intended behavior of the contracts, and then it would produce this report whether the functionality is correct with respect to the specification or not. We have been very happy to work with many large crypto projects, many based in Singapore, which is why we're here also to meet them physically. So, yeah. So this is the point that you would use before you deploy on the blockchain, and then once you have done this, you would, the products typically deploy the code on the blockchain, and to help them figure out what's happening on the blockchain, which was a very common concern, by the way. So many of the tech teams were really, it's really opaque what happens to your contract after deployment. So we have built this monitoring solution that would help the projects track the health and the security of their smart contracts on one side, and on the other side to also allow users to see if these contracts are in a secure state, so to speak, so to give additional trust to the users of these smart contracts. So the pilot client for this monitoring solution was actually Kyber Network. And we have already deployed it. The internal teams are using it. They're checking very interesting properties that's, for example, tracking the exchange rates that are used on their decentralized exchange compared to other exchanges and so on. And currently we're looking to deploy this kind of monitoring solutions to many other crypto projects in this space. Okay, so that's basically all from me. This is the core technology. As I mentioned, everything is running, it's operational, so feel free to stop by. I will be right over there after these talks here, and I can show you how this works. And I'll be happy to take any questions. Yeah, thank you.
All right, any questions?
This is an issue that you're working on, a very important issue that's been raised for years. There are so many problems and bugs with smart contracts, including ridiculous ones. There is a company called QuantStamp that seems to be quite ahead of everybody, at least in my mind. They have built a proprietary database of these bugs, if you will, that they run smart contracts against. Can you please address how your company is different from a company like QuantStamp?
Sure, that's a good question. So QuantStamp is actually building a security protocol that allows users to upload contracts and then check them. They're actually not building the technology used to checking the smart contracts. So we're actually completely orthogonal. In fact, just a few days ago, we announced that we're integrating the security scanner. The security code scanner that we have built will be integrated together with the QuantStamp protocol. So we're actually in collaboration working together towards this. So they're kind of combining this technology and bringing it to user, but we are focusing on building the actual technology used to certify the smart contracts. Yep.
Who would you like to take?
Maybe let's start from the front.
Okay.
Thank you. Excellent presentation. I'm curious about the business side. How are you approaching companies? Are you dedicated to certain verticals, or what kind of companies are more feasible for your solution?
Sure. So we work with large crypto projects. We have typically long-term partnerships with them as a security provider. So we start we provide security audits for them to make sure that they're secure before they deploy, and then we continuously monitor their smart contracts and provide them additional. We essentially provide security service to them. We also work with several enterprise clients in Switzerland, including Swiss banks, that are looking at this space. They're typically not looking at public blockchains. They're looking at more private solutions. But we have also built products that I did not talk about for those kind of clients. So it's a long-term partnership with crypto projects, essentially. Question there?
So what do you think about the plausibility of the insecurity of smart contracts being obviated by the deployment of formal verification methods?
Could you repeat or clarify?
To what degree do you think that the current insecurity of the current ways of deploying smart contracts can be addressed by deploying formal verification methods?
Oh, so actually, so it will happen. What will happen is it's very similar to what happened in chip design, where you also have small pieces of designs that are very critical. So what happened there is exactly this: people started formally verifying these chips, and then issues were, that raised the level way higher. So that's exactly what's happening to the space of smart contracts. So we'll see that in the next year, it will be demanded that all the essential contracts that are implemented exchanges or any complex functionality would be formally verified. And those would, of course, be significantly more secure than, let's say, what happened last year. This would not make things 100% secure because you verify only specific properties, but the bar would be way, way higher than it was 1 year ago.
You have time for one last question?
Over there. There, the man with the shirt, yeah. Yes, right. Yes, no. Okay, it's fine. Yes, that was
okay.
my...
No, in continuation to our earlier discussion. So, in case if a blockchain is already built and if you find any bugs in it, so how would you, if I have millions of data already available, so what would be a suggestion in terms of if some contract has to be, some code of the contract has to be corrected? So will it be a separate chain spawned, or how do you help organizations in?
So this is very hard. You either would have to rescue the contract, get the funds out, and then you wouldn't basically care about it, or you would try to upgrade it if this functionality is implemented. I think there will be a follow-up question maybe. But it's very hard. Or you would do a fork, which is very hard to do, and as we saw,
it's going to be an expensive. It's going to be an expensive aspect.
Yes, so also as Sarah mentioned in the previous, so that's the problem. These contracts are immutable on the public blockchains, right, which significantly complicates handling these issues.